Okay, so good afternoon, good evening, good morning, everybody, and welcome to the webinar, the SCAR Geoscience webinar series. Just a few words about SCAR for those who don't know what SCAR is. SCAR is an international scientific committee for Antarctic research, and is a thematic organization of the International Science Council. Has been running for several decades now, since the International Geophysical Year, and is the maximum worldwide coordination for Antarctic science, and is initiating and developing international scientific research. It's also providing advice to the Antarctic Treaty Meeting and for two main international organizations like IPCC and UNFCCC. SCAR works under the executive SCAR Executive Committee, which is basically preparing all the documents and executing what the SCAR delegates set up every 4 years. And it's the SCAR Executive Committee is led by the president of SCAR, which is now Gary Wilson from New Zealand, and 4 vice presidents elected by the SCAR delegates. And then there is the executive director, which is Chandrika Nath, and the secretariat of SCAR, who are preparing all the documents. The SCAR works with 3 main science group, which is the geoscience group, the life science group, and physical science group. And we are the chief officer of the SCAR Geoscience Group. So is Jesus Galindo Zaldivar from Spain, Naresh Pant from India, myself from Italy, and Julia Matilde Ferrante, who is also from Italy, and she has a fellowship to help us in our management. So the geoscience group is includes several action and expert groups. Each of them are a specific target and lifespan. We are running a webinar for each of them to inform about their activities, their products, how to be involved. And today we will hear about the International Bathymetric Chart of Southern Ocean. And next, this is the list of the all webinars. So the next one will be on October 1st. And then the rest after that. You can find the list and also the link to register, to get the Zoom link and to follow the next webinar in our SCAR Geoscience page. So I don't want to be...
Put the link in the chat.
Yes, I'll put a link in the chat as well. You can also find this link and all the information in the SCAR Geoscience portal. But yes, I'll put the link in the chat. And okay. So Boris and Finn today will speak about the International Bathymetric Chart of the Southern Ocean, and I think I'll leave you the floor.
Thank you, Laura, for the introduction. I'll share my screen. Can you see it?
Yes.
Very good, very good. As Laura said, I'm Boris Dorschel from the Alfred Wegener Institute in Bremerhaven, Germany, and together with Finn Warnke from the University of Auckland in New Zealand, we want to present you in the scope of this seminar the International Bathymetric Chart of the Southern Ocean, short IBCSO. Okay. What is IBCSO? IBCSO is a regional mapping project of the subcommittee of JEPCO subcommittee of regional undersea mapping. IBCSO is part of the Nippon Foundation JEPCO Seabed 2030 project. IBCSO is a SCAR expert group. And most of all, IBCSO is an international collaborative effort. What all this means, I'll get to in a bit more detail in a second. So, what is the connection of IBCSO and JEPCO? JEPCO, as some of you might know, stands for General Bathymetric Chart of the Ocean. This is a very old initiative, started in 1903, and JEPCO aims to provide the authoritative, publicly available map or bathymetric data set for the world's oceans, for the entire world's oceans. JEPCO operates under the auspices of the IHO, the International Hydrographic Office, and the IOC, International Oceanographic Commission of UNESCO. And many of you may have seen the JEPCO product, the JEPCO grid or the JEPCO map, as it is the background map in Google Maps. And although we are familiar with global maps that cover the entire globe and give us the full picture, I actually like this picture that you see here even more so, as I think it's a more honest picture. What you see here in colors is the part of the seafloor that has actually been mapped or constrained by direct measurements. And all the other parts that are derived from predicted bathymetry or from satellite, low resolution satellite derived altimetry are blacked out. And this gives a totally different image of the state of information we have for the seafloor. As opposed to a full coverage, we're only looking at about 25%. And how does IBCSO plays in with JEPCO? As I said, the IBCSO is a project of the subcommittee, JEPCO subcommittee on regional undersea mapping. So IBCSO was created by JEPCO to produce the best possible map for everything south of 50 degrees south. That is the entire Southern Ocean and the southernmost 10 degrees of the Atlantic, Indian, and Pacific Ocean. And where does the Nippon Foundation JEPCO Seabed 2030 project comes into the mix? JEPCO and Seabed 2030 are closely related. Seabed 2030 also is a global mapping initiative with the aim or the mission of 100% coverage, seafloor coverage, so a completely mapped world's ocean seafloor. Furthermore, Seabed 2030 is a flagship program of the UN Ocean Decade. It is organized in one global center and 4 regional centers, and Seabed 2030, funded by the Nippon Foundation, is the working part that generates the JEPCO grid. Seabed 2030 is tasked to produce the JEPCO grid, the annual JEPCO grid. The 4 regional centers of Seabed 2030 are indicated here. You've got the pins in the map on top and description underneath. And we here at ARVI are the Southern Ocean Regional Center. So we oversee the production of the best possible map south of 50 degrees south, here indicated in red on the map. But what's a project without the people? This is the face of the Seabed 2030 Southern Ocean Regional Center, also known as the IBCSO production team. this is us. Most of us are based in Bremerhaven. Finn is based in Auckland, and we actually do the work, collecting data, generating the grids, programming algorithms to handle billions of data points, and eventually to produce the IBCSO dataset that then becomes part of the JEPCO part of the JEPCO map. And as I said, the SCAR is an IBCSO expert group, as it deals with the waters, with the Southern Ocean, the waters, the ocean surrounding Antarctica, and is under the geoscience group, as you can see here, hence the webinar today. But we have close links to BATMAP, here red underlined, BATMAP 3 just released, as BATMAP is the extension of the seabed under the ice sheet. So there's a natural connection between IBCSO and BATMAP, and also with rings, which have just been presented a couple of weeks back here in this webinar. Rings, an initiative to connect the seabed with the sub-ice sheet topography, focusing on crucial areas like the sub-ice shelf topography and the grounding zone. And last not least, IBCSO, or furthermore, most importantly, IBCSO is an international collaborative effort. And I was thinking how to best illustrate this. And what you see here, I came up by showing showing which institution actually make IBCSO possible. So what you see here are more than 100 institutions worldwide that have either collected and or contributed data, provided data to IBCSO to make the map better and better every day. Or they host, have hosted people that are involved in IBCSO or have been involved in IBCSO in the past. It's a very global, pretty much global spread. And yes, it is a truly global initiative. And with this, I'd like to leave this map where you can see, only can see the Antarctica as the thin white line at the bottom, and hand over to Finn to show the real IBCSO.
Oh, thanks, Boris, and thanks to all of you for joining, and hello from my side as well. I have been with IBCSO for more than 5 years. In the first part as a data engineer, and was with a colleague of mine, Sasha, mainly involved with the preparation of the actual product in the end. And what you can see here, and what I will show in the next couple of slides, is a fairly high-level overview of what we actually do in order to create such a product from millions and millions of input data points, as Boris already mentioned. Could you put the next slide, Boris? Yes, and this slide might be a bit overwhelming, but on the left-hand side, you see a QR code to the publication inside the data, which is illustrating the whole workflow and the IBCSO version 2, which was published in 2022. And on the right-hand side, this is, I think, one of the most central figures in terms of the workflow. The workflow was first internally and now also officially called a Seahorse. I think that's quite fitting. And I will briefly guide you through this. So if we look at the upper left part, the grayish boxes, the pre-processing step, and I think everybody who's working with data of any kind knows that this is always one of the most steps in order to get anything out in the end. And what we have to deal with, especially with older data sets, which we scrape from public and open access repositories, is to remove all the outliers, to check if the projection is correct, and you know, all those things involved with general data processing and cleaning. Afterwards, the actual workflow consists of 4 different stages. Stage A, the so-called harmonization, in the end produces a harmonized database. So what does it mean? All our input raw data comes in any imaginable different form and formats and data types. So for example, we might have multi-beam data sets, or we might have an XYZ ASCII files, and all those data gets extracted, and we standardize the data in a common projection, which would be the IBCSO projection, which we registered in late 2020. And in the end, we have a database which we can use to further work on it. And in the second stage B, the tiling, we split up our whole data set into different tiles in the different chunks, which is necessary in order to further inspect and clean the data and to make it more convenient on our local workstations, but also for all the other processing steps enables to use parallelism in order to speed up the computation times. In stage C, the weighted statistics, we mainly compute a weighted block median. Block median, what that is illustrated in the middle left box of the figure. So in the smaller left inset map, you can see input data. This is one example tile, and you see different color-coded dots. And these dots represent, in case they are just a single line, single beam data sets, for example, and the ones which actually cover the whole swath are multi-beam macros on the data. And what we do is we split the whole tile into different block median windows. In this case, for version 2, 500 by 500 meters, and we calculate the median depth, the coordinates of the center, well, of the actual data point in this case, and then also some additional statistics in order to verify our data. And you might ask, what's the reason for this? This case, we can make the data production workflow much more better handle, because otherwise we would have a whole lot of data sets in some areas and basically none in others, and the heterogeneity would severely influence the output product. And so after stage C, we basically have a harmonized tile database, which is split into block median, and then we actually go to the final magic, stage D, where we create the product. And what we first do is we use the bed machine, or nowadays BedMap. Boris introduced a couple of slides back, in order to have the under ice sheet topography available as well. What we do is we sample that grid, and then we have two tracks in our gridding workflow. The first track is the background surface gridding, which is a low resolution representation of the whole of the Southern Ocean and the topography underneath the ice shelf, which is basically our background grid. But then, in order to lose all the details which are provided, especially by the high quality multi-beam data set, we also have a second track where we grid only the high quality data. And you might ask, okay, what is high quality? This is this depends on attached metadata information, like the sensor type, for example, multi-beam versus single beam, but also the year of acquisition, because more recent data tends to be in much better quality than some of the 90s or 80s, for example. And then in the next step, we take both the background surface grid and the sparse high resolution grid, as you can see in the two small inset maps down on the right-hand side, and we bend them together. Bending means kind of a data blending, where we make sure that we don't have steep scars at the intersection of two grids. And then we generate a so-called composite grid. But in areas where we have really low data coverage, we use information from predicted bathymetry, so satellite-derived bathymetry, in specific the SRTM15 plus grid. And this is basically used to infill the gaps, as the name implies. And from the merged composite product, we derive two metadata grids. One is the regional identifier grid, where each cell not only doesn't hold the actual depth information, but a unique identifier which we can link back to our metadata table with all the adjacent information. In addition, we also create a type identifier grid, which is an easy way in a GIS system to check, okay, what is actually the input for this depth in the specific cell. For example, if you have a research area somewhere around the Antarctic Peninsula and you want to see if it's actually constrained by direct measurements, or if the data value or the depth in this case comes from satellite-derived bathymetry, for example. And for the final products, we create two outputs, the IBCSO grid with sub-ice bathymetry, which is essentially the BatMap based topography. And we also add the BatMap, or previously the BatMachine ice surface elevation grid, and then you get a nicer presentation with the ice surface elevation as well. So Boris, to the next. Exactly, and Boris mentioned, this is version 2. There was a version 1, obviously, which was published in 2013, also based at the Alfred Wegener Institution. And when we compare those two, just the key numbers actually here are that we increased the coverage from south of 60 degree during version 1 to south of 50 degree for version 2. This, but also the combination of more recently acquired data in the last decade, we saw an increase of the overall data points from over 4.2 billion to over 30 billion, which is a substantial amount of data to handle. And currently the grid resolution is presented in 500 by 500 meters projected in the IBCSO polar stereographic projection, which by now hopefully should be included in every major GIS application, which wasn't the case when we started. Next slide, please. Yeah, and now I want to visually guide you through the product creation, which I theoretically explained on the previous slides. So this, as you can see, is the nice end product. This is the RGB colored hill shaded map of the Southern Ocean and Antarctica, obviously. Next slide. And this is the making of. So I talked about the difference between version 1 and version 2, and this is nicely illustrated here. The dashed circle indicates the northernmost extent of IBCSO version 1, while the outer boundary of the map extent is 50 degrees south. Next, please. And what our database consists of 1.5% single beam, which seems low for the amount of coverage here is illustrated. This is mainly due to the resolution. So in fact, these are just like really, really narrow stripes seafloor. But there is quite a vast amount of single beam data that has been collected over the past decades. Next slide. And if we add all the multi-beam coverage, which is covering about 23.8% of the extent of the oceans in the IBCSO area, we get a total amount of about 25% of the Southern Ocean, which is currently covered with direct measurements, which is quite substantial, but there is still a lot of room for improvement. Because next slide, please. What you can see here, and it's just a bit different shading, but this is actually a density map, and so the areas which are more yellow and are more colored. For example, in the Drake Passage or around the South Sandwich Islands, those are indicating, or for example, also in the Ross Sea, all these areas indicating that we have a really, really dense and potentially high quality data coverage in those areas, which obviously leads to better representation of the actual seafloor bathymetry. In contrast, if you look to the Western Weddell Sea, where there's basically no yellow on the map, then you know that all the seafloor topography or bathymetry in this case is constrained mainly by satellite-derived bathymetry. And this is, for those of you who've been in that area, mainly due to the fact that there's a year-round ice coverage and basically no way for a research vessel to go there, as Boris and I experienced back in 2019. And also, and I think this is one of improvement over the last years, is the coverage of around East Antarctica, which is comparably sparse compared to West Antarctica as well. Next slide, please. So and Boris already introduced that the sheer amount of data and is obviously not collected by us on its own, but the combined effort of more than 23 countries, 105 organizations, and 129 different vessels or platforms. Vessels and platforms, because not all of this comes from research vessels, obviously, but there are also some on ice sheet seismic surveys involved, and all different kinds of other types where people derive depth measurements the one way or the other, which is immensely helpful because those are the areas where vessels normally can't go. Yeah, and all the different rainbow colors here illustrate different different individual surveys. Next slide, please. And this is finally the end product, here nicely illustrated as a map. Next slide. All right. And now, since you heard all about the actual creation of the product, the next question that might arise is, okay, how can I get that? Which is fairly easy. You see the QR code in the right lower end, and you can also see the DOI code. All the data is publicly available at the Pangea data repository, and there are a couple of different products. This product here is a PDF digital chart of the Southern Ocean, which is perfect if you want to hang up in your office and show in some Zoom meetings as a background. Something I would suggest doing, but also look at for inspiration, because it's a really nicely illustrated representation of the cumulative effort. And next slide, please. As I introduced earlier, there's one version of the actual grid with depth measurement, which includes the ice surface elevation for version 2 coming from Batmachine. Next slide. And the alternative version is the subglacial topography, also derived from Batmachine, illustrated here. And next slide, please. So the two derived products I introduced earlier. So the RID, the regional identifier on the upper right, shaded in different rainbow colors, each representing a unique data set. And on the left, the TID grid here indicated in two colors, mainly in green, which is barely visible, and in bluish colors, multi-beam coverage. So you can, on the first glance, identify, okay, the data is the depth values are coming from this specific data type. And I didn't mention that before, but all of this data is not only available in the projected IBCSO polar stratigraphic projection, but also in the geographic projection WJS 84, of course. Next slide. Yeah, and we didn't stop after the publication of IBCSO version 2, but in the past year, we saw the first publication of the IBCSO 2024 annual release. So this is going to be a kind of a rolling release on an annual basis, as the name indicates, where we will publish, first update and then publish intermediate versions between major releases with the most up-to-date grid representation. Bear in mind that these are mainly the most up-to-date product we have. They are not, there might be some issues still remaining in the grid. And if you happen to find one of those, we are really glad if you could relay the information to us and could solve the problem afterwards. And these data are available on the IBCSO webpage, ibcso.org. Also here linked with a QR code if you're interested, besides many other interesting and helpful information as well. Next slide, please. So before I end my part, I want to give you a small sneak preview of what's coming next. So what we did in the past years was streamline the processing pipelines on the HPC of a high-performance computing system. This is mainly due to think of my colleague Sasha, who is mainly in charge of this. There is ongoing effort in refining direct measurements through data cleaning, QA and QC, trying to make sure that we get the best representation possible. We also will integrate, and already started, high resolution topography, mainly satellite based, and the ultimate goal is to increase the resolution of the product, from currently 500 by 500 meter to 100 by 100 meter in the future. And here are 3 examples. Thanks, Boris. The first example you can see on the small inset map is coming from fairly close where I am currently in New Zealand. So this is Macquarie Island, which is about 32 kilometers in length, and you can see, in the comparison from the previous picture, that the resolution and the level of detail is obviously much higher when looking at it in 100-meter resolution. And the 2 other examples are coming from South Georgia Island and the southern part of the Antarctic Peninsula, which is covering some nearshore areas, also much higher resolution, which is, as Boris introduced, one of the most trickiest part, the transition between the shelf and the actual under ice topography. Next slide. And with this, I hand back over to Boris. Thank you very much.
I take over here and give you just continue from what Finn has just said, and give a bit of background about the annual release. It's, as he said, is a rolling release, but it's a beta version, and the intention of doing so was that we thought we want to have a working product. IBCSO should be useful for people who are working around Antarctica. So what we do, we take all the data that we can get, in a perfect world, also those of the last Antarctic season, and integrate them into the annual release to be released between September or November, just in time for the following Antarctic season, so that people who work around Antarctica have the most up-to-date information. As Finn said, the result, the products can be a bit spiky. They're not as nicely brushed and cleaned as the major versions, but nevertheless, you know, you will know where data is. You will see the data as good as it is, and it all comes with a coverage polygon. So if you want to extend coverages, or if you want to do mapping, want to run mapping surveys, you know where to concentrate, not to duplicate efforts, and to be most efficient. What we do as well, ongoing, is we constantly look for satellite-derived bathymetry and integrate the latest versions, that we have all improvements in our background data as well. Update ice islands and ice surface topography. Some islands are missing in some data sets, others are missing in other data sets. So what we do, we crawl over the map and integrate as many coastlines and islands as we can, and also island topographies. We update the sub-ice sheet topography. There's Batmachine and Batmap, and we make sure we get the most up-to-date sub-ice sheet topography with the highest density. And then ongoing work for the next couple of years is the IBCSO version 3. IBCSO version 3 will be with the same extent. It will be everything south of 50 degrees south. But as Finn has already mentioned, we increased the resolution to 100 meters. And this comes with an entire zoo of own problems. First of all, it's every cell in IBCSO version 2 will become 25 cells in IBCSO version 3. So we have to think about mechanisms of providing the final product without breaking without running in all kind of RAM issues on the user side. So that's further down the line. Other problems are clever tiling, a lot of cleaning, a lot of errors that disappear, that are block medianed out in 500 meters, show up in 100 meters. So this will take a lot of work. And coastlines, we need coastlines in a resolution that support 100 meter grid, that we can oversample to an extent that we get a nice image. So this will keep us busy for a while, But as you've seen in a sneak preview, we think it's worth the effort, and we'll go for it. There will be a lot of licensing issues as well. Some of the data sets we've only received for 500 to be used in a 500 meter resolution, so we have to downsample them. But these are all we address issues step by step, and we're quite confident that we will eventually have in the not too far future we'll have an IBCSO version 3 to present, and we'll have, if everything goes according to plan, within the next month, we will have the first mock-up versions of the grid to get a feel what we're up against. It's very exciting times. I hope I have it before we are heading down to Antarctica this early next year. And yeah, as I said, it's a global effort. You've seen the work of so many people and institutes and institutions and crews and scientists collecting all this data and putting it all together. And if you think it's worth the while, and if you have data, and if you want to get involved and help us reach the 100% and would like to contribute to data, this is very simple. There are various ways. There's, for example, you can take the JEPCO avenue, use the JEPCO submission form. The data will eventually land on our desk, will be channeled through down to us. Same is true for the International Hydrographic Office digital database, DCDB, Data Center for Digital Bathymetry. They have also, they accept data contributions. And again, if it's south of 50 degrees south, it'll find its way to us. If your data sets are complicated or you want to have an alternative way, just get in contact with us. You can do this either over our website, or you can contact us, or you can just simply email us. And we do whatever we can to facilitate a data transfer to help you get your data into IBCSO. And we publish the final products, the versions in international peer-reviewed journals. And the idea is whoever helps to make this happen should be a co-author or has been a co-author on IBCSO version 2. And we are happy to expand it infinitively for IBCSO version 3, because without data, without people, this project cannot work. It's all about the people eventually. And with this, I thank you for listening, and I hope you enjoyed our webinar.
Thank you. Thank you very much, Boris and Finn. Very informative. Are there any questions from the audience? I don't see the question. Matilda, you have to...
Yeah, no question for now.
No, Jesus is raising his hands.
Well, Boris and Finn, thank you for this nice presentation about the stage of the IBCSO project. And I think that one of the main issues is the lack of data, because really there is 25% of coverage of the Antarctica, and there are very big areas that are very scarce data. Then, in this case, two questions. One, it is possible to aim to the different Antarctic program to cover this area? What do you think, or the most interesting area? And the second is the IBCSO 3 with 800 meter resolution is very nice, but probably is only this resolution is only reached to very small area, maybe the Bransfield Strait or the Scotia Sea, but not in other area that there is nothing, no, practically. What do you think about?
I addressed the first question first. Seabed 2030 is a great project, but does not have the capacity to collect data. It's about accumulating existing and accumulating existing data. So yes, it needs ships, and it needs people to go out and collect data in the areas that are where no data are. And if you look at the distribution of the data, you can see that it's mostly the open ocean, deep water, and it's the areas where ice limits the access. So yes, we're happy for everybody going out there, but there is no project that for a coordinated, organized surveying. This is just would just be ginormous, and it's beyond the scope of any scheme that we know of.
Okay.
The other question regarding the 100-meter grid, we follow two strategies there. We will never produce anything with a higher resolution than 100 meters. So this is our target resolution eventually. And yes, of course, in deep water, the footprints are so, and the spacing of the beams is so wide that we will not get 100-meter resolution across a swath. But this doesn't really matter, because we will always be able to combine the cells and to a lower resolution. So this is what we end up with, and we fill the gaps anyway, and we bend it, so there will be interpolation between for the holes in the between the empty cells. But it will be our future base from which we derive other products. And one key phrase or catchphrase that springs to mind is multi-resolution grids. If we have a 100-meter resolution grid, we will be prepared for multi-resolution grid, where the resolution of the grid is suitable for the specific depth band. And we prepare for this, and this is where it comes from. Yeah, but yeah, you're absolutely right. In the deep areas, the data spacing and the footprints of the data will not allow for a full 100-meter coverage. It's beyond the capabilities, technical capabilities.
Thank you.
Any other question?
I may repeat question.
Yeah.
No, perhaps there is another question. Well, no, my last question is, well, generally when we do marine cruise, we acquire both bathymetry. At the same time, we acquire also with the echo-sounder the reflectivity. Is possible to have some map of reflectivity at the same time, like the bathymetry, or what do you think about it? Because both the data generally are acquired at the same time.
Yes, yes and no. Backscatter data, amplitude data, the useful backscatter data have only been recorded fairly recently, and so a lot of the old multi-beam data doesn't have backscatter data with it. So a significant, if you take away all the multi-beam data without backscatter data, the coverage is even smaller, and we have not addressed it, as it comes with an entire new set of problems: inclination angle, normalization of impedance. It's we're busy as we are. It's yes, we think about, we get asked about backscatter because it adds so much additional information about the substrate and the seabed, but it's beyond the scope and beyond what we can do with who we are. Sorry for that.
Thanks for this additional question. No more. Okay, thanks.
I'd like to ask a question. Hi. How are you? Is EBSO also, does EBSO also constitute an archive for the data sets from which it makes them up? Like, are you collecting the data sets, and are you somewhere where somebody that wants those data sets can come to request them?
Nope. EBSO is not a data archive. It's a definite no, and a quiet maybe. It's a definite no. Okay. Because we're not a data center. We do not provide access to the data, and because that would overburden us. That's the distinct no. The quiet maybe is, of course, we have all the data in our working archives. We have them locally to produce the in close vicinity to the high performance cluster to produce the map. We clean the data and we prepare the data. So we physically have the data, but we're not distributing data. This is just for us to work on. But which is helpful for everybody who wants to use IBCSO. IBCSO comes with a extended, sophisticated metadata collection. So what we provide with the IBCSO datasets, the datasets means the product datasets, not the base datasets, to avoid confusion. So what comes with the product datasets is a GeoPackage coverage file that contains information on the data sources as well. So if the data set has a DOI, it's in there. So you can use these information for specific areas and locate the source data wherever it's publicly available. Some data isn't publicly available, and then these fields are empty. But a surprising amount of data is actually publicly available, and the metadata file would help you to locate it.
I want to say that, first of all, this is a very impressive effort and amazing and well done. It's I can understand how much work it is. And I think that this aspect of having the data archived on your system, even if you don't let it out, is a very important thing, because data gets lost. And this is a very big problem that we face all the time. Even if you don't let it out, having it is a very good thing. Another question is regarding the land area, and that is you were talking about the sub ice, and you were talking about the topography for the sub ice. It's all those radar surveys, I guess. And are you actually working on these? Are you actually collecting these, or is it somewhere else?
Finn, would you like to answer, or should I go?
I can briefly start and you can take over. So no, we are not collecting any data onshore. This is, as you said, mainly done with radar-based methods or airborne gravimetry, inversion-based depth that are derived. All the information comes from previously BAT machine, now would come from the new BATmap 3, which is also an initiative or one special interest group of SCAR. And we, at least it was mainly actively involved. We were in close contact with working on that and making sure that the transition is as smooth as possible. But maybe, Boris, you have some more information on the more recent side.
Yeah, it's for a complete map and for a seamless transition, you need the sub ice sheet and ice shelf topography, and but we take it as is. We're not. It's an established product, and this is what we work for. We can't from the IBCSO side, from the bathymetry side, we can't add new information to the sub ice sheet topography. So we see the challenge in a seamless transition and free of artifacts, so that we, in an ideal world, we would define a zone from the seabed under the ice shelves, across the grounding zone, and under the sub ice sheet. That we have the most realistic transition from the seabed to the sub ice sheet topography. But beyond that, we take it as is. It's BATmap's job there, and the other way around. BATmap, we in contact, and they always get the first up versions of seabed, because that they know what they have to work towards to make it as smooth as possible.
Yeah, thank you.
I have a question about the activity that you do as a SCAR action group. One of the problem is that perhaps the geologists are very keen on the bathymetry, you know, so all the time when we have a cruise, we always try to collect the data and then to provide you with, you know, to improve your map. But sometimes, I don't know, biologists or physical oceanographer, they probably, not all of them are so, they have the good knowledge about how important it is to have a good bathymetry, and so they speed up. They need to, you know, ship time is always very precious, so that could be a problem. So I was wondering if, as an action group, you can try to plan some activities in order to inform the other groups, the other communities, how powerful it is to have a bathymetry and how this could be a community effort, because you need any ship which is sailing in the Southern Ocean could collect the data. So because I know you are a group, you are a team, you are a technical team which is working on that specific project, but you can probably use your SCAR network to improve the knowledge about the impact of the work that you do. So then you can get more a broader community which is pushing toward, you know, making a bigger effort. We know that we as a geoscience group, we had a recommendation to these delegates a few years ago, and the delegates actually adopted the way that each nation should actually collect the bathymetry data during transit. And so, because we really believe that this is very important, but this is a geoscience initiative, and it would be nice to have life science and physical science and more groups also going the same direction. So I want think about it. You are an action group of SCAR, so use this to make that, you know, route in the future. You need a committee with members from many countries, so perhaps you can enroll some early career scientists who are generally more enthusiastic than seniors, to spread the information, to engage with the community. So think about a plan.
I think the Open Science Conference, the upcoming, would be a good first place to start to become more visibility.
Yeah, it's
Well,
okay.
we will have our site meeting there, but yes, yeah, no, I hear you. It's
yeah, maybe just start discussing with physical oceanographer and see how they could help, how can contribute. I got a question, I guess, in the chat. I don't see it anymore, but that was about the float. I don't know, Matilde, you sent me a message. Somebody was asking if floats can actually collect some bathymetry data.
they can. We've been contacted by the hydrographic offices about the use of sub-ice floats for bathymetric information, and of course, we also looking into the use of animal-borne depth measurements. The huge database that has just been published by my name memory. I please apologize. Yes, but yeah, absolutely. We in areas where there's no other information, we take whatever's there. Yes, we're quite creative. We're not picky. We're not. That's the beauty of working on a scientific project rather than in the surveying world. We want to get as much information as we can, and especially around Eastern Antarctica, we have large areas with, especially shelf areas with very low data density. And I have two particular areas of interest. The one is of Oatsland, where we have literally no data whatsoever. I'd love to go there is probably a bit ambitious because it's always so ice packed. That's why there's no data there. But get a way of getting depth information there. We don't even know where the troughs of the outlet glaciers are. We have really no clue there. It's totally terra incognita. And the same is true for the Southwest Weddell Sea, where we have a couple of lines running across, but it's very sparse, and that would be amazing. Yeah. So whatever gets us information there, we're happy to use. And Argo floats, obviously, especially the under ice Argo floats, it can be very helpful.
Mm-hmm. Okay. Any other questions? Is there anything in the chat, Matilde?
One last comment. ATCM has published a resolution that encourages the collection of bathymetric data in the Southern Ocean for primarily for safety of navigation. But this can also be used for IBCSO, obviously. So there is a general encouragement to collect bathymetric data also while on transit.
Good. That's a good news. I didn't know. I should know, but yeah. Okay. So it's quite late in Italy, in Europe, actually. Thank you very much, Boris and Finn, for doing this. Not during regular working hours, but also thanks to everybody who attended. And this has been recorded, so after Matilde's clean a bit, put it in the right format, will be published in the SCAR Geoscience portal. And so I invite you to the next webinar, which is October 1st at 11 a.m. UTC. And it's about ANTOS, Antarctic Nearshore and Terrestrial Observation System. So yeah, I see you next time, and have a nice evening or day, depends.
Thank you very much.
Thank you.
And
Thank you.
Bye bye.
looking forward.
Yes.
Thanks for having us.
Bye bye.
Bye bye.